Hello everyone, welcome to my class. In today's class I am going to cover double angle identities, half angle identities and product to sum identities. Now let's begin the class right away. First, let me review the algebraic skill that we discussed in our last class. Special product formula: a minus b times a plus b. If you FOIL these two factors, then it gives you a square minus b square. Other terms cancel there. Perfect square formula: a plus b outside is square gives us a square plus 2ab plus b square. Similarly, a minus b outside is square gives us a square minus 2ab plus b square. We can combine the terms in fractions using LCD. For example, a over b plus c over d turns out to be, here the LCD is BD, so BD, then multiply AD, then plus BC, so AD plus BC over BD. Similarly, if you have a minus sign there, then it turns out that AD minus BC over BD. Another quick recall: the sum formula that we covered in our previous class. Sine alpha plus beta turns out to be sine alpha cosine beta plus cosine alpha sine beta. Here the plus sign remains as it is, only sine and cosine alternate. Now in the second formula here, cosine of alpha plus beta turns out to be cosine alpha cosine beta, then minus sine alpha sine beta. In this formula, the functions remains as it is, only the sign changes from plus to minus. Similarly, the third formula, the sum formula for tangent alpha plus beta turns out to be tan alpha plus tan beta over 1 minus tan alpha tan beta. So here the plus remains as it is on the numerator, so only changes the plus to minus on our denominator. I hope you are familiar with this formula. Now, if we let alpha equals to beta, I'm talking these angles, then we have the following double angle formula. Sine of 2 alpha, so here on this sum formula, let's put both alpha and beta equal to alpha. Then here is a sine of 2 alpha. On my right side, sine alpha as it is, this becomes cosine alpha plus cosine alpha sine alpha. So that means we have these two like terms, we can add them. So this gives us simply 2 sine alpha cosine alpha, which I wrote down here. So sine of 2 alpha equals to 2 sine alpha cosine alpha. Let me scroll down. And by the way, sine of 2 alpha is not equals to 2 times sine alpha. Great. Next, cosine of 2 alpha equals to, again from this formula, it turns out that if beta equals to alpha, then cosine square alpha minus sine square alpha. That's what I wrote here. Next, if we change cosine square alpha to 1 minus sine square alpha, then we will have this formula, 1 minus 2 sine square alpha. Similarly, if we change sine square alpha to 1 minus cosine square alpha, and then this gives us this last part here, 2 cosine square alpha minus 1. So cosine of 2 alpha has this 3 formula. Similarly, tangent of 2 alpha turns out to be 2 tan alpha over 1 minus tan square alpha. Great. Next, that's better. The power reduction formula. So cosine square alpha from this identity here. So bring 1 to the left side. That means we have cosine of 2 alpha plus 1 equals to 2 cosine square alpha, and then divide both sides by 2. Then it turns out that cosine square alpha equals to 1 plus cosine of 2 alpha over 2. I hope this comparison makes sense to you here. Similarly, sine square alpha equals to 1 minus cosine of 2 alpha over 2, and tan square alpha turns out to be 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. I hope this formula makes sense to you all. Next, I know there are a lot of formula in today's class. Now, half angle formula, if that's better. If we let alpha equals to theta over 2 in a reduction formula, sine square alpha equals to 1 minus cosine of 2 alpha over 2, then let's replace alpha equals to theta over 2. So then here the left side, sine square theta over 2 equals to 1 minus cosine 2 alpha. If you cross multiply, then 2 alpha equals to theta. So then I can replace 2 alpha by theta. So 1 minus cosine theta over 2 as it is. Then from this step to the next step, take the square root both sides. It turns out that sine theta over 2 equals to plus minus under the radical 1 minus cosine theta over 2. So now we have another formula. This is the half angle formula for sine. Let me summarize. Let me change again theta back to alpha and give you the formula in the next slide. So here, so sine alpha over 2 turns out to be plus minus under the radical 1 minus cosine alpha over 2. Similarly, cosine of alpha over 2 turns out to be plus minus under the radical 1 plus cosine alpha over 2. So only minus to plus different for sine and cosine. And for tangent of alpha over 2 turns out to be plus minus under the radical 1 minus cosine alpha over 1 plus cosine alpha. Or if we multiply by conjugate of denominator in numerator and denominator, then it turns out that tan alpha over 2 equals to either 1 minus cosine alpha over sine alpha or sine alpha over 1 plus cosine alpha. Great. Now let's move on. Another formula, the product to sum identities and sum to product identities. First, quick recall. Cosine of sum of angles and cosine of difference of angles. We know this formula. Then let's add these two formulas. Then here, the second term on our right hand side, this cancels. Minus sine alpha sine beta plus sine alpha sine beta cancels. So only I'm adding the first two terms on our right hand side. So this becomes simply 2 times cosine alpha cosine beta. This equals to left hand side, sum of the left hand side, cosine of alpha plus beta plus cosine of alpha minus beta. Then let me do this. Yeah, that's better. Then divide by 2 both sides in the next step, which I did here. Now this is the product to sum formula for cosine. So this side is in the product form, and this side the angles are in sum forms. There is also a plus there. So this formula is the product to sum formula for cosine. And similarly, you can find the product to sum formula for sine. So let me summarize on the table below. So here, so cosine alpha times cosine beta turns out to be 1/2. I'm just copying this part. Cosine alpha plus beta plus cosine alpha minus beta. Similarly, if you repeat this procedure for sine, then we have sine alpha times sine beta turns out to be 1/2 cosine of alpha minus beta minus cosine of alpha plus beta. So here, left hand side both sine, the trig function, and my right side both trig functions are cosine, cosine. Next, sine alpha times cosine beta. If we alternate the functions here, then on the right hand side it turns out that 1/2 times sine alpha plus beta plus sine alpha minus beta. Again, both sine functions. I hope it makes sense to you all. And similarly, cosine alpha times sine beta turns out to be 1/2 sine of alpha plus beta minus sine alpha minus beta. Great. Next, if we let alpha equals to u plus v over 2 and beta equals to u minus v over 2, then add these two, alpha plus beta turns out to be I'm adding these two fractions on my right side here. So 2 same LCD, V cancels, so 2u over 2 cancels, so simply u. Similarly, if we subtract these two fractions, then alpha minus beta turns out to be simply v. So then from the above product to sum formula, so let me work on this formula here, which is here, I wrote down sine alpha, let me scroll down, sine alpha cosine beta equals to 1/2 times sine alpha plus beta plus sine alpha minus beta reduces to, let me go down here, this reduces to, on my left side here, alpha, here's alpha is u plus b over 2, so sine u plus b over 2 times cosine beta, beta is u minus b over 2, u minus b over 2 equals to, on my right side, 1/2 as it is. We know alpha plus beta is u, so sine of u, and plus as it is, and alpha minus beta is v, so sine of v. So now let me rearrange the term. So let's write this right hand side to the left hand side and multiply by 2 both sides. This gives me on my right side 2 times sine of u plus b over 2 times cosine of u minus b over 2. So here on our left side we have the sum sine of u plus sine of v, and on our right side this is in the product form. So the formula is called sum to product formula for sine. I hope this derivation makes sense to you all. Now let me summarize. Let me change again u and v back to alpha and beta and give you the formula in terms of alpha and beta. So then sum to product formula are sine alpha plus sine beta equals to 2 times sine alpha plus beta over 2 cosine alpha minus beta over 2. Let me scroll down. Now similarly, it turns out that sine alpha minus sine beta equals to 2 times cosine alpha plus beta over 2 sine alpha minus beta over 2. Now similarly for cosine alpha plus cosine beta turns out to be 2 times cosine alpha plus beta over 2 times cosine alpha minus beta over 2. And cosine alpha minus cosine beta turns out to be minus 2 times sine alpha plus beta over 2 times sine alpha minus beta over 2. So left side is in the sum or difference here, and right side is in the product form. The functions are in product here. Sine times cosine, cosine times sine, cosine times cosine, sine times sine. And keep in mind here the cosine produces the minus and sine, and cosine in the plus form, both cosine, and so on. Great. Now with those bunch of formulas, now let's do some example. Let's do example 1. Example 1, given sine alpha equals to 5 over 13 and alpha in second quadrant, find the exact value of sine of 2 alpha, cosine of 2 alpha, and tangent of 2 alpha. I hope the question makes sense to you. So first, let's rewrite sine alpha in terms of ratio of sides of right triangles and use Pythagorean identity and find the remaining side of the triangle. Then we can easily evaluate or find the values of those functions. So first, let's begin the solutions. Here, sine alpha equals to 5 over 13. We know sine function is the ratio of perpendicular over hypotenuse in right triangle. So b is 5, then h is 13. Now you can find the value of b, means the base of the right triangle, using Pythagorean identity, and it turns out that b is plus minus 12. So then cosine alpha, let's find the value of cosine alpha. Cosine alpha is base over hypotenuse. So base is 12. I use minus 12 here. The reason is cosine alpha in the second quadrant is negative. So b is minus 12 over h is 13. I hope this minus makes sense to you all, because our angle is in second quadrant and cosine is negative in second quadrant. Now, that's better. Now, let's find the value of sine of 2 alpha. We know the formula, sine of 2 alpha equals to 2 sine alpha cosine alpha. And let's plug the value, 2 as it is. Sine alpha is 513 given. Cosine alpha we just found negative 12 over 13. Simplify, gives you negative 120 over 169. Great, so that's our final answer. Similarly, for cosine 2 alpha, the formula is cosine square alpha minus sine square alpha. Plug the values, so cosine alpha is negative 12 over 13 square, is this number, minus as it is. Sine alpha is 5 over 13 square, with this number. Simplify, we have the same LCD, we can easily solve these fractions, that's better. So here the LCD is 169, so simply subtract the numerator, 144 minus 25, then the final answer, it turns out that 119 over 169. I hope it makes sense to you all. Now similarly, let's find the value of tangent of 2 alpha. We know tangent of 2 alpha is sine of 2 alpha over cosine of 2 alpha. We know the value of sine 2 alpha we found here, which is this number, and cosine 2 alpha, again we found the value of this one here. So let's divide the first result by second result, then the denominator cancel out, so we have negative 120 over 119. That's the final answer for tangent of 2 alpha. I hope this computation makes sense to you all. Great. Now let's move on. Example 2. Given to us, cosine of 2 alpha equals to 120 over 169, and the angle 2 alpha lies in fourth quadrant. Then find the exact value of sine alpha and cosine alpha. Let's begin the solutions. First, let's find the position of angle alpha. So since we know that 2 alpha lies in fourth quadrant, so that means 2 alpha lies in between 3 pi over 2 to 2 pi. That means 270 degree to 360 degree. Then divide both sides by 2. Then it turns out that alpha lies between 3 pi over 4 to pi. That means alpha lies in second quadrant, and we know in second quadrant only sine is positive, cosine is negative. So let's move on. Now let's use this formula here. Cosine of 2 alpha equals to 2 times cosine square alpha minus 1. We know this formula earlier. Let me show you the formula. I think we have the 3 choice for the cosine of 2 alpha here. 1, 2 and 3. I use this formula, and in the next step I use this formula for finding the value of sine alpha. Let me scroll down again. We are here, example 2. Okay, so this is the formula, and so here our goal is to find the value of cosine alpha. So what do we know here? We know cosine of 2 alpha is 120 over 169, and I add the 1 both sides, so bring 1 to the left side, so plus 1 equals to 2 times cosine square alpha alone on the right side. Let me go this way. Then simplify on the left side, take LCD. LCD is 169, then 120 plus 169 over 169. This means this left hand side here. I hope this computation makes sense to you all. Right hand side as it is, 2 times cosine square alpha. Then to find the value of cosine square alpha, divide by 2 both sides, which I did here, and simplify this number is this one, and take the square root. Hence cosine alpha equals to plus minus radical 289 over 338. And since we are in quadrant second, so our cosine alpha is negative, so let's pick the value of negative. Then radical 289 is 17, radical 338 is 13 times radical 2, and to avoid the radical in the denominator, multiply by radical 2 on top and bottom. Then it turns out that the cosine alpha equals to negative 17 times radical 2 all over 26. I hope this makes sense to you. One more time, this minus I picked minus because cosine alpha is negative in second quadrant. Great. Now similarly, let's find the value of sine alpha. Again, we know the formula of cosine 2 alpha in terms of sine is 1 minus 2 sine square alpha. Cosine 2 alpha is 120 over 169 is given to us. Subtract 1 both sides, so bring 1 to the left side, that's minus 1, and right hand side is simply negative 2 times sine square alpha. Simplify the left hand side. We know we can easily simplify these fractions by taking LCD. Simplify it, turns out this number. Right hand side as it is. Next step, divide by negative 2. Next step, take the square root both sides. Now we have this equations here, and we know sine alpha is positive in second quadrant, so I pick the positive value here. And to avoid the radical on denominator, we multiply top and bottom by radical 2. So our final answer is sine alpha equals to 7 times radical 2 over 26. So we found cosine alpha, found sine alpha. I hope these computations make sense to you all. Now let's move on. Example 3. Find the exact value of the equations A through D. First part A. Part A, sine of angle 75 degree times cosine of angle 75 degree. Keep in mind, on our earlier trigonometric functions value chart, we only know the values of 60 degree and then we jump to 90 degree. Now we are finding the value of sine and cosine at 75 degree. So let's begin the solutions. So let's apply the formula product to sum formula. Then this is the formula we have earlier. Then alpha is 75 degree, beta is this 75 degree. Then this turns out that 1/2 as it is on my right side, sine 75 degree plus 75 degree, both alpha is 75, beta is 75, plus as it is, sine as it is, alpha minus beta is 75 degree minus 75 degree. Now next, so here 1/2 as it is, 75 plus 75, let's add these angles, which is 150 degree. We know the value of sine 150 degree, and here 75 cancels, so sine 0 degree. 1/2 as it is in the next step, sine 150 degree is simply 1/2 plus sine 0 degree is 0. Then send this 1/2 inside, so we have 1/2 times 1/2 is 1/4. Now we know the value of sine 75 degree times cosine 75 degree, turns out that 1/4. Great. I hope this computation makes sense to you all. Now let's move on. Next, let's find the value of sine of 22.5 degree. Great. So this times, let's apply the half angle formula. Since 22.5 equals to 45 over 2, then by this half angle formula, sine alpha over 2 equals to this formula. Under the radical, 1 minus cosine alpha over 2, alpha is 45 degree. So here, and we know cosine 45 degree is 1 over radical 2. Then we have the fraction and numerator. Let's solve the fractions first here. So again, this giant radical. So the giant radical under, simplify this numerator. LCD is radical 2. Then we have radical 2 times 1 is radical 2 minus 1. Then all over, the denominator is 2 as it is here. I hope this algebra makes sense to you all. In the next step, this radical 2 is, we can bring it down here. So we have the giant radical. Under the giant radical, we have radical 2 minus 1 over 2 times radical 2. Again, we can multiply by radical 2 on numerator and denominator. Then it turns out that then the final answer is under the giant radical 2 minus radical 2 over 2. I hope this makes sense to you all. Now great. Now let's move on. Similarly, let's compute part C. sine of 75 degree plus sine of 15 degree. Let's begin the solutions. We know this formula, sum to product, sine alpha plus sine beta equals to 2 times sine alpha plus beta over 2, cosine alpha minus beta over 2. So here, alpha is 75 degree, beta is 15 degree. So plug the values. So sine 75 degree plus sine 15 degree equals to, on my right side, 2 as it is, function sine as it is, alpha plus beta is 75 plus 15 over 2 as it is, then cosine as it is, 75 minus 15 over 2. Great. I hope everyone's following me on this step here. Now the final lines here, let me scroll down. 2 as it is, 75 plus 15 is 90, divided by 2 is 45, so we have sine 45 degree. In the next, cosine as it is, 75 minus 15 is 60, divided by 2 is 30, so we have cosine 30 degree. Next step, plug the value. 2 as it is, sine 45 degree is 1 over radical 2, and cosine 30 degree is radical 3 over 2. Simplify, it turns out that radical 6 over 2. Great. I hope it makes sense to you all. In the final step here, these two cancel out, and to get rid of radical on denominator, let's multiply by radical 2 on numerator and denominator. So our final answer, it turns out to be radical 6 over 2. I hope you understand this part. Great. Similarly, let's do part D. Find cosine theta over 2 if cosine theta is negative 8 over 17 and theta is obtuse angle. Let's begin the solutions. So you know this half angle formula for cosine. Cosine alpha over 2 equals to under the radical 1 plus cosine alpha over 2. So put alpha is theta. So then here cosine theta over 2 equals to under the radical 1 plus cosine theta all over 2. We know the cosine theta is given to us negative 8 over 17. So everything rest is same here. And now simplify this fraction. So that means 17 times 1 is 17, and then minus 8 is 9 over 17. This is the fraction in our numerator. Denominator 2 as it is, and we have the giant radical. So you simplify, this turns out that 3 over radical 34. The 17 times 2 is 34 under this radical, and radical 9 is 3. Great. Great. Now let's move on. Example 4. Write the following product as a sum and sum as a product if necessary. Part A is given product form, so let's write in sum form, and part B is given in sum form, I mean difference here. Then we need to write in terms of product on our right side. So let's begin. Part A, cosine 15 theta times sine negative 3 theta, that's given to us. We know sine function is odd function, so sine of minus 3 theta becomes minus sine of 3 theta. So in the next step, in cosine 15 theta as it is, so minus as it is, and let's apply the formula product to sum. So that's the formula. Let me show you the formula here. The formula is here. The formula is here, product to sum formula, and I'm using this formula here. Let me scroll down. We are in example 4. So this part comes from the formula. Now just the routine computations, minus 1 half as it is, 3 theta plus 15 theta is 18 theta, so sine 18 theta, plus as it is, 3 theta minus 15 theta is minus 12 theta, so sine of minus 12 theta. And in the next step, again, sine is odd function, so take this minus here. So we have sine 18 theta minus sine 12 theta, and distribute this minus. So then this becomes plus, this becomes minus, which I wrote down here. I hope this makes sense to you all. So our final answer is 1/2 times sine of 12 theta minus sine of 18 theta. Great. Let's do part B. Sine of 7 alpha over 6 minus sine of 5 alpha over 6. Use formula. It turns out that 2 times cosine sum of the angles over 2 times sine difference of angle over 2. Now simplify. Here on my numerator we have a fractions. So 7 alpha plus 5 alpha is 12 alpha over 6, means simply 2 alpha, and that 2 and this 2 cancel, so simply alpha. So you have 2 times cosine alpha. In here 7 alpha minus 5 alpha is 2 alpha over 6. LCD is 6, by the way. That means 2 alpha over 6 and over 2. So this 2 and 2 cancel, so alpha over 6, which is here. So our final answer is 2 times cosine alpha sine alpha over 6. I hope this makes sense to you all. Now let's move on. Now let's do verifying trigonometric identities. These types of problem we did in our previous sections. So part A, given fractions, cosine of 2x over sine square x, and our right side is given cotangent square x minus 1. So let's begin from the left hand side. So copy the left hand side, apply the formula. So here cosine 2x is cosine square x minus sine square x. Sine square x in the denominator as it is. In the next step, distribute this denominator to each of the terms of numerator. So we have cosine square x over sine square x minus sine square x over sine square x, but this cancel out gives me simply 1. Also we know cosine square x over sine square x is simply cotangent square x, and minus 1 as it is. That's the right hand side. So we use the double angle here. So here we verify the trig identity given in double angles. Great. So let's move on. Let's do part B, the last questions for these sections. So left hand side is 1 minus sine square of 2 theta. Right hand side is 1 minus 4 sine square theta plus 4 sine 4 theta. So this 4 is a power. Great. So let's apply the formula. We know this algebra scale. A square minus 2ab plus b square is a minus b outside square. So let's begin from right hand side this time. So RHS copy down here. And this simply means 1 minus 2 sine square theta outside square. If you FOIL the right hand side, you will get this left hand side. And in the next step here, again we know this formula. 1 minus 2 sine square theta is simply cosine 2 theta. Outside square is as it is. So this outside square is same as here, cosine square of 2 theta. And again we have this formula here. This is simply the Pythagorean identity. We know sine square x plus cosine square x equals to 1. So take sine square x to the right side. This gives you cosine square x equals to 1 minus sine square x. By the way, here x equals to 2 theta. So we have cosine square 2 theta equals to 1 minus sine square of 2 theta. And that's the left hand side. We verified this trig identity. Great. So we finished this section 6.4. Thank you.